Yeah. So it's apparently so cold because it was snowing on Table Mountain.
Yeah.
Had it already started snowing by then? Yes, you may go to the bottom. Okay, so here is what I have that we did last. So there was my graph, and I have my y-intercept, so I substituted in, and then I substituted the other point. Then we had this one. This one over here was the next one. And then we also said, what happens if I swap the coordinates around? Did it matter? We landed up with exactly the same gradient. Once we got the gradient, we substitute any point to get my C value. Then I gave you another one where it only looked like I only gave you 1 point, but we realized that it is going through my origin, which is 0 and 0. So that left me with y equals to negative 4x. And I think that was, no, we had another one after that, or around that time, where I give you a point and the intercept. So we substitute the intercept, we substitute the point, and that was the Thursday. So what the other group realized was that they actually only needed to know one method. So they preferred to only do the gradient method. So even if I do have an intercept, even if I do have the intercept, I can change it into a coordinate. Y is my negative 4. So 0 is my x. And that way I have two coordinates. I can still do a gradient calculation. I can still substitute in. Okay? So they decided to only remember that one, change it, do the gradient, substitute to find the intercept. So we're going to now maybe practice one or two because it has been a week. And then we will look at determining the equation from a table. So that was from graphs. We'll also look at it from a table. So let me just put all of this back in the cupboard. Paper. Why haven't you gone to the bathroom yet? Oh, okay, if you want to wait, you can wait. Okay, find a Koki to write with. Okay, we are group 2. And today is the 31st of August. Okay, so I'm leaving you with an exercise. So I'm asking you to determine the equation, and I'm going to give you a graph. I'm just looking for my ruler. Oh, ruler. Use a stencil for now. Okay, I'll zoom in a little bit. So determine the equation of the straight line given to you. Just one and only one step of help. I'm looking to make it equal y equal to mx plus c. Just give me a moment. Should be almost done, if not already done. Sorry. Okay, let's have a look at that one. So I'm going to do it the other way. Okay, I don't know my y-intercept, so I'm going to have to find this coordinate. Do I get given an x or a y? X. So this coordinate would be -2 and 0. So now I need to calculate my gradient. My gradient is y2 minus y1 over x2 minus x1. Substituting in coordinates, I'll take that one first, 0 for y, minus 2 for x, and I write it immediately so I make sure that they keep together as a pair. Then I have minus 1 for y, so it's now another minus, so I'm protecting, and 3 for x. So 0 minus minus 1 is positive 1. Minus 2 minus 3 is minus 5. So my gradient is negative 1/5. Okay, negative 1/5. So therefore, I no longer have y equals mx plus c. I can now cut out the m and paste negative 1/5 plus c. Now, in order to find the c value, I need to substitute in either one of the points. It does not matter which one. I'm going to substitute in negative 2 and 0. 0 for y. Negative 1/5 is my gradient. Negative 2 is my x plus c. So I will have a negative times a negative is positive. 2 is the same as saying 2 over 1. So 1 times 2 is 2. 5 times 1 is 5. C is positive and single, but it's not by itself. So taking the positive 2 over 5 over, and it becomes negative 2 over 5. So therefore, my final equation is negative 1/5 x plus, not plus, sorry, minus 2 over 5. So my x and y will always remain x and y as the equation. It is the m value that we have to find and the c value that we have to find. Any questions? Just waiting for you to finish writing so I can show you your next one to practice. Yes, go to the bathroom. Okay, our next one, and 3, 2, no objections, 1. Okay, just zooming in so we can see those values. So you're determining the equation. I'll give you 2 coordinates. It is 1/2 and 5, and negative 1 and negative 3. All right. see most of you are still busy. Okay, 30 more seconds and then we're going to mark that. Okay, let's have a look. So we have 2 points. I'm trying to get to y equals to mx plus c. Calculating my gradient, where I take y coordinate minus the second y coordinate over x2 minus x1. I will choose this one, for instance, as my first one with my y on top and my x below it. My minus 3 is my y, my minus 1 is my x. 5 minus minus 3 means plus, so 5 plus 3 is 8. A half plus 1 is 1.5, which is 3 over 2. Now you can either take the easy way out and go check on your calculator, or we can tip and times. 8 over 1 times 2 over 3. It's going to give me 16 over 3 as my gradient. Therefore, I now know that I can cut the m from there and paste it with 16 over 3. And I'm still trying to get the c value. Now I can take either point to substitute in, and you can take the one with the fraction, or you can take the one with not the fraction. I'm going to go without the fraction. So -1 and -3 is what I'm substituting in. -3 for y, I should have written the other side, but oh well. 16/3 is my gradient. My x is -1 plus c. That's going to give me negative 16/3 plus c. So when I take it over, it's going to be positive 16/3. Now, if I wanted to practice my fractions, I would give it over 1 times by 3 to get the same denominator. So I would have -9/3 plus 16/3 equals to c. -9 plus 16 should give me 7/3. Therefore, y equals -16/3 x plus 7/3. So yes, I can throw fractions in there, and no, you won't always get nice whole number gradients. So it is, you have not done something wrong if you land up with a funny fraction. Any questions, grade 9s? You see, it's the same thing we did before. We calculated the gradient, we changed our formula, we substituted in a point, and updated our formula again. And for the next two examples, that's exactly what you are going to do. I lied. The next one is a trick question. The one after that is what you will do. Are we ready for our next one? 3. You need to say no if you are not ready, please. Ready? Okay. So my next, not that one, this one. I need an equation. Will it be in the form of y equals to mx plus c? Why not? I'm not going through any one y value. Yes, there's no y-intercept. Also, I said to you, y equals to mx plus c is only for diagonal lines. Is this a diagonal line? What kind of line is this? Vertical line. And if it's a vertical line or a horizontal line, it means it will either be x equals or y equals. That's it. There's nothing else. Is this going to be an x equals equation or a y equals equation? An x equals, because it's going and cutting at my x-axis. So what is that equation? X is equal to 2. That's it. Done. That's your equation. So whatever the axis it is cutting is the letter that you use. Whatever the number they give you is the number that you use. The next one we're going to do together, and I'm doing it because there's quite a few of them in your activity at home next week. So I want to know that you've at least seen it before you have to do it. Let's scroll out a little bit. There we go. So those that are still busy with the one before can also, and those who are still busy or able to start the next one can start the next one. So I have that's an X. I have a Cartesian plane with a straight line and it cuts at 3 on the y-axis, and I tell you that it grows 1 unit to the left and 3 units up to get to that point. But I don't tell you what that point is. So just draw that for me, and then we will work through it together. Yes. Yes, you may. It should be in the cupboard there. When Eden comes back, we will do this example. Okay, while Eden's still coming back, let me quickly do our absence fee check. Who were you at in period 2? Who? Nicholas is here, Matthew's absent, Christina's here, Eden's here, Daniel's in the other group. Logan's here, Jordan's absent, Sinalizu's here, Olile absent, Jessica's here, Amy's here, Matthew's here. Okay, I'm only waiting for 30 more seconds. Hopefully she's back in those 30 seconds. Okay, let's look. So we have to still determine a straight line equation, which means my goal is still y equals to mx plus c. So I need to be able to calculate my gradient and then substitute in a point to find c. Currently, as it stands, I do give you enough information, but I actually have to interpret it a little bit first. So here where I cut my y-axis at 3, what is that coordinate at that point? X is 0, so the coordinate is 0 for x and 3 for y. Okay, so that's my one coordinate. Now, I do give you the point of the other coordinate, and I give you information that will get you the other coordinate, but I don't give you the coordinate itself. So if I'm going from 0 and I'm going to the left by 1 unit, is that going to change my x value or my y value? My x value. And if I'm going to the left by 1 unit, what is the new x coordinate? -1. Fantastic. And then I start at 3 for y, and I'm going up by another 3. So what is the new y value? It's 6. And now I have 2 coordinates, which means I can calculate my gradient. So m is equal to y2 minus y1 over x2 minus x1. And my first y coordinate, doesn't matter which one I choose. Let's go with that one for first. It's x, I write with it. My equation says minus. That one's y is 6. This one's y is -1. 3 minus 6 is -3. And 0 plus 1 is 1. So that gradient is going to be -3. So what I do now, therefore, I update my equation. -3x plus c, and I can choose either point to find my c value. I'm going to use 0 and 3. 3 for y, -3 times 0. 0 times -3 is just 0. So c is equal to, and therefore my equation, my final updated, why aren't we, there we go. Therefore, y equals to -3 is my gradient and +3 is my intercept. So even though I could substitute any point at this here to find c, why did I choose 0 and 3? It is kind of the smallest numbers, yes. What else? Why would I specifically choose x to be 0? If I had the choice of finding coordinate that 0 is x, why would I use that for my substitution? Rather than -1 and 6. Yes, Amy. It cancels out, so I don't have to take anything over to the other side. So whatever is in the y is my c value. So if x equals 0 is an option, I'm always going to choose it because it's less work. Does not mean that doing the other one won't get you the same answer. Definitely will. It's just going to be more work. But that's something that you gain as you do more and more functions. Okay, so the next thing we need to look at is determining the equation when the only thing I give you is a table, not a graph. Can I take this off the board? Everyone agrees? Okay. So determining the equation from a table. So let's just zoom in a little bit. So what do I give you? I give you a table with x and y values. What do? Well, we know that we need to start and find out a way to get y equals to mx plus c. The first thing I do is calculate the gradient by using any 2 points, rather the coordinates. And that will give me my m value and therefore update with the m value. And then lastly, I would sub in any point to find the c value. And I would therefore update the equation with the c value. Nicholas, you already finished writing. Wow, good. Good skill to have, quick writing. So we're going to do one together, possibly even two together. And then the first thing we'll do tomorrow in class is you're going to practice one by yourself. Okay, so I want you to draw the table that I'm about to show you. So example, determine the equation, and that's the table I give you. Yes.
What does it say after using any two
Points, and then in brackets it says coords for coordinates. So let's draw the table, please. Example, determining the equation, and that's the table that I give you. So when you go through your functions booklet, your notes on this says specifically any 2 points next to each other. But if they are all on the same straight line, you should use any two, and it should give you the same answer. If you use ones and it doesn't give you the same answer, then it means it's not a straight line. So when I say calculate by using any 2 points, you can literally use any two. So what's the first thing to remember, we've looked at it before, is that the x and y together make a coordinate. So -3 for x, -9 for y. Logan, choose another one for me, please. 0 and -3. So I'm going to start the same way that it told me to, is starting with y equals to mx plus c. And then it told me to calculate my gradient by using any 2 points. And you can see I chose a point and Logan chose a point. So it's literally any 2 points. So I'm going to take -9 with its partner of -3, minus from the equation, -3 from the second coordinate, and 0. So I get -9 plus 3, which is 6, over 3 minus 3 minus 3. Oh, sorry, it's -6. What am I saying? It's -3. And negative divided by negative is? And 6 divided by 3? 2. So therefore, I am now at a point where I have 2x plus c. Now, Eden, choose a third point for me. It can be the same, can be anything else. -2 and -7. So substituting that in, -7 for y, -2 for x, plus c. 2 times -2 is -4. Take my -4 over, becomes +4. -7 plus 4 is -3. And finally, I will get 2x minus 3. And we could have done it again, and I did have more time with the other class, and we did do it again where we chose different points, and we still got to exactly the same point. So what I want you to do this afternoon, take 2 minutes choose a different set of values and confirm that you get the same equation. So you can start now if you're ready with writing while we wait for those announcements. So take another set of values and try and find the same equation. Use different coordinates to find the equation. So I'll say it again, you can use any coordinates, whether I circled it or not, just don't use exactly the same. So your exercise is use different coordinates to determine the equation. Currently the bell's only ringing in 5 minutes. Did you get the same equation, Eden? Amy, which two coordinates did you choose? These two together. Okay. So Amy chose those two. So let's see, we have y equals to mx plus c. What I'm trying to get, my gradient, I would say -7 minus -9. And once again, it doesn't matter which one I put first, as long as my 7 has its partner of x of -2 and -3 has its partner of -9. So -7 plus 9 is going to give me 2. -2 plus 3 is going to give me +1. So my gradient is 2. Therefore, we have y equals to 2x plus c. What did you substitute in then, Amy? the third one. Okay, so then she substituted in -1 for x, -5 for y. So I would have -5.
Please,
That's minus
as it is
2.
raining, please stay in your grade 3 venues.
Okay, -5.
Just two announcements for Miss Windall's grade 10 math lit class is to go to B111 for grade 4. And Miss Williams' grade 11s are to go to B20 after break. Thank you.
So we land up at exactly the same place, even though we took a whole different set of coordinates. Sorry if you can't see that. Okay, you can pack away grade 9s. It is break time, lunch and all that.